Let's talk instead about a mystery interstellar object that was spotted by astronomers last week. It could be the oldest comet ever seen. It's only the third time that we've actually detected an object that has come from beyond our solar system.
The sky had a quiet new story to tell, and people who watched the heavens listened closely. An object that moved faster and on a stranger path than most visitors had been picked up by a sky survey in Chile. It flashed briefly in the images, a small, fuzzy dot at first, then a thin coma and a tail as sunlight warmed its surface. The team that found it gave the discovery a temporary label, and soon astronomers around the world realized this was not a normal comet from inside the solar family. Its path through space was hyperbolic, meaning it came from outside the sun's neighborhood and would leave again. The initial report sparked excitement because interstellar visitors are rare, and this one promised to arrive near the sun at a time when many telescopes could watch closely. The discovery felt humble and grand at the same time. It began with a routine sweep of the southern sky by an automated telescope system that looks for moving objects. On that night, an unusual trail caught the software's attention and the human eyes that check the alerts. Follow-up observations confirmed the motion and the brightness, and as more images came in, it became clear this object was on a fast, straight trajectory through the neighborhood. Astronomers compared the new orbit with known patterns and found the signature of something from interstellar space. This reality turned a small blip into a rare scientific chance to study material that formed around another star. As teams hurried to point instruments at the visitor, the calendar became part of the story. By measuring its path, scientists calculated when the object would come closest to the sun, a moment called perihelion. That date gave observers a deadline. Telescopes both on the ground and in orbit planned campaigns to capture the object as it brightened and reacted to solar heating. The arrival date, when the comet would be at perihelion, was fixed to late October, and that timing focused attention and resources. People who lived in the southern hemisphere and mid-latitudes watched for updates, and observatories adjusted schedules so they would not miss the brief window of peak brightness. The visitors' behavior offered both puzzles and chances. Early images showed a coma, a cloud of gas and dust around a compact core, and hints of a tail pushed away by sunlight and the solar wind. Spectrographs were trained on the glow to split the light into its components, searching for the fingerprints of water, carbon compounds, and other volatile molecules. Those measurements could reveal how similar or different the object's composition was to comets born in our own system. If the composition matched, it would suggest that the raw materials for worlds like ours might be common across the galaxy. If it differed, it would open fresh ideas about how planet-making varies from star to star. Scientists understood that every spectrum, every light curve, and every change in brightness could tell a piece of that story. Size estimates created lively discussion. When a fuzzy object sports a bright coma, it is hard to tell how big the solid nucleus really is. Some early calculations put the nucleus size in a wide range, with some analyses suggesting it might be as large as several kilometers across. Others warned that the coma could be inflating the apparent size, making the core look bigger than it is. That debate mattered because a larger nucleus holds more record of its formation and more material to study, while a smaller one would be more easily pushed around by outgassing and might react differently to the sun. Teams carefully compared images taken with different filters and at different times to narrow down the true size. Orbit details gave comfort to people worried about collisions. The calculated path showed that the object would not come near Earth. Its closest approach to the sun would lie between the orbits of Earth and Mars, and its nearest pass to Earth would still be millions of kilometers away. Scientists emphasized that this visitor posed no impact danger. Instead, it provided a safe and fleeting opportunity to study alien material. Those clear reassurances helped move the public conversation away from fear and toward curiosity. Telescope operators could focus on data instead of defense, and citizen astronomers could plan safe ways to observe the object from a distance. Planning the observations felt like preparing for a one-time experiment with no do-overs. Time on large telescopes is precious and scheduled months in advance. But when something unique appears, plans shift. Space-based observatories offered sharp views without atmospheric blurring, while ground observatories provided flexible coverage and large collecting areas for faint signals. Smaller robotic telescopes kept a running record of brightness, and radio and radar teams prepared to try if the object came close enough. Teams around the world coordinated to make sure the visitor would be photographed, scanned, and sampled in light as often as possible during the perihelion window. The aim was to gather a rich data set that could be mined for years. The object's journey also became a laboratory for methods. Astronomers used it to test new imaging techniques, to try different ways of subtracting background starlight from crowded fields, and to refine models that estimate how much dust a comet is producing. Some telescopes use time-lapse exposures to trace the faint tail as the visitor crossed dense star fields, and other teams combined images in different wavelengths to tease out the sizes of dust grains. These practical improvements matter because as surveys get better, scientists will find more interstellar wanderers and will need reliable tools to study them quickly and well. The lessons learned from this visitor would make the next discovery easier to analyze. Attention shifted from pure data to stories of origin. By tracing the object's past trajectory backward, researchers looked for a likely origin direction in the sky. Unlike previous interstellar visitors, this one seemed to come from a different corridor of the Milky Way, pointing toward a dense southern region of stars. That hint suggested it might have formed around a star very different from the Sun, adding weight to the idea that planetary systems throw off material in many directions, and that interstellar space carries a mix of pieces from many homes. This wandering chunk of ice and rock might thus preserve a record of conditions far across the galaxy. As perihelion approached, observers watched for dramatic changes. Comets sometimes break apart, flare suddenly, or develop jets that point in particular directions. Any such event could reveal internal structure, weak layers, pockets of volatile ices, or a fragile assembly of smaller pieces. For this visitor, small outbursts were detected and logged, but nothing suggested catastrophic breakup during the main observing window. Each flare was valuable because it illuminated material that lay below the surface, and because the timing of activity helps scientists model how heat penetrates the nucleus after a long journey through deep space. Every burst of dust or gas was a clue. The public response was a mix of awe, confusion, and excitement. News outlets ran images that showed a glowing object with a delicate tail, and social media filled with conversations about what the visitor might mean. Amateur astronomers asked when and where to look with their own telescopes, and teachers used the event to explain orbital mechanics and the differences between asteroids and comets. The discovery rekindled a long-standing public interest in connections between planetary systems and in the basic question, how common are the ingredients for life across the galaxy? For a while, the sky gave a clear, visible prompt to think about these deep questions. Behind the scenes, scientists prepared the data for all who would use it. Images and spectra were shared through online archives, circulars, and collaborative platforms so teams everywhere could analyze the same observations. Graduate students began new projects, instrument teams refined calibration steps, and theorists updated models of how interstellar objects behave in a new stellar environment. The shared rush of activity is a hallmark of modern astronomy. Discoveries are rarely the work of a single group alone, and the best science comes when many pairs of eyes examine the same evidence from different angles. Once the arrival date had passed and the object swung around the sun, attention turned to how it faded. As it moved away, sunlight waned, and the coma thinned. Observers tracked the decline in brightness and looked for lingering jets or changes in the tail that might persist. Those later data points help refine mass estimates and models of how dust escapes the nucleus. Even as the object receded into the dark, the record of its passage remained, a catalog of images and spectra that researchers would mine for months. Each measurement added a small piece to a larger puzzle about material made in other stellar systems. Scientists also reflected on what the arrival meant for the future. Powerful survey telescopes now coming online will sweep the sky more deeply and more often than previous instruments, and that promises to turn rare finds into regular events. As discoveries accumulate, astronomers will be able to compare many interstellar visitors and build a statistical picture of their sizes, compositions, and frequencies. That shift, from one-off wonders to a growing catalog, will sharpen answers to big questions about how material moves between stars and how common different building blocks of planets are across the galaxy. The arrival date for this visitor was a step toward that richer future of comparative study. The event also showed the need for careful communication. Early reports sometimes stretched the facts or gave wide-size estimates without clear uncertainty ranges, and scientists repeatedly emphasized what was known and what remained uncertain. The process was a reminder that science advances through measurement, analysis, and revision. Quick headlines can spark interest, but real understanding grows from careful work. Astronomers welcomed the public interest while asking for patience as data were refined and interpretations matured. In practical terms, the visit was a training ground for future coordination. Observatories practiced sharing alerts and prioritizing follow-ups. Space agencies checked how quickly they could redirect instruments, and surveyed teams tested software that flags unusual motion. Those procedural improvements are quietly important. When the next interstellar visitor arrives, the community will be better prepared to observe it thoroughly. The arrival date of this object thus mattered not only for its own study, but also for strengthening the system that studies all transient things in the sky. For many, the scientific rewards are personal and human. The discovery inspired students to imagine careers in astronomy, gave teachers a fresh, real-world example for classrooms, and reminded people that the galaxy is a dynamic place. A tiny piece of rock and ice passing through the solar neighborhood became a focal point for curiosity about the wider cosmos. Even though the visitor would leave and fade, the knowledge gained would stay and feed future discovery. The arrival date marked the moment humanity leaned in and listened carefully to a small, alien messenger. Looking ahead, the record of this visitor will be compared to others and used to test models of how planetary systems evolve and eject material into interstellar space. Isotopic ratios, volatile abundances, and dust grain properties will all be compared with samples from comets in the solar system and with laboratory studies. Those comparisons are the slow work of building science, and the data gathered around the arrival date will be part of that long effort. Each new data point helps refine the picture of how common water and organic molecules are in the galaxy, and whether the early materials that built Earth are rare or widespread. The arrival also fueled conversations about the future of space missions and the ways humans might one day reach or study interstellar objects more directly. Some engineers and mission planners pointed out that if interstellar visitors are found earlier, small, fast missions could be designed to intercept or fly by them. Those missions would be technically hard and expensive, but the payoff, direct sampling or close inspection of material formed around another star, could transform our understanding of the building blocks of planets. Scientists also use the event to think about how data is shared and preserved. Large surveys produce torrents of images and measurements, and the community discussed standards for metadata, for archiving raw and processed data, and for crediting teams that contribute rapid observations. Clear rules help early career scientists, amateurs, and professional teams work together without confusion. Those discussions might sound bureaucratic, but they matter because good practices let the whole field move fast while keeping records reliable and fair. There was also a human comfort in the event. In a world often full of troubles, a clear and shared scientific event gave many people a chance to focus on learning together. Science centers planned public talks, libraries ran small viewing nights, and teachers built simple projects around the visitor's orbit and brightness. Those small acts of shared curiosity helped people feel connected to the larger story of the galaxy. Finally, the arrival date itself became a small historical note. Years from now, scientists will point to that date when they compare datasets and when they teach about how the community responded. The lessons from the campaign, its successes and its limits, will shape how future teams react to the next visitor. Each such event builds experience and knowledge, and that steady record is how science gains confidence. For the moment, however, the clear fact remained: humanity had watched, measured, and learned from a brief, distant visitor. The arrival date marked a brief chapter in which curiosity, care, cooperation advanced human knowledge about the galaxy and inspired exploration.